My name is Chee-Kheng Chng. I go by my initials, CK. I'm a senior postdoc here at the Australian Institute for Machine Learning. I work at the intersection of AI, computer vision, and space technology. Space missions are becoming increasingly complex. Spacecraft nowadays venture far away from Earth to the Moon, Mars, and beyond, where human intervention is not a reliable option anymore. So that means that spacecraft that now flies today has the ability to perceive, understand, and act entirely on their own. They have to autonomously navigate, avoid hazards, land safely, making essentially mission-critical decisions without waiting for instruction from Earth. Rather than just telling you about my works, I'd like to show the demo about a system that my co-author Sophia and I have been developing. It's called Stella. Stella is an in-house AI system that's designed for a planned space mission. But the goal of this space mission is to create a resource map of the Moon. So as the spacecraft orbits around the Moon, scanning for potential water sources, Stella look at the images that's captured by the onboard camera of the spacecraft, analyze it, detect and try to identify any craters that's observed on the images, and then Stella would use these craters as landmarks to figure out its position and where it's pointing. That way, every data collected will be geotagged with the positions that Stella provides, hence creating a resource map of the Moon. The space environment is not friendly to the AI and computer vision technologies. You have harsh lighting because you don't have atmosphere shielding you. You have long shadows. You have featureless terrains. Unlike on Earth, when you go on the roads, you have painted lanes, you have road signs. But in space, we don't have that luxury, at least not yet. Secondly, data is scarce. You can't just put a camera on top of your car, hit the records, and just drive around the city and collect your data set. It doesn't work like that for space. It's very expensive, it's very complicated to go to space and collect data. But last but not least, we are working with very limited resources. Space mission typically restricts with power and computing budgets. We can't just send bulky, power-hungry GPU into orbit. Any algorithms that we deploy has to be efficient, lightweight, and still perform reliably under these constraints. What makes Stella special is that it is not just a proof of concept for academic purposes. It is actually being prepared for actual space mission. That is, I think, very rare in this field. Lots of the algorithms, they get published and they get shelved. So for our team, knowing that Stella is both academically recognized and space mission ready, that's something that we are genuinely happy, excited, and proud of. These are the kind of works that I aspire to keep doing. There are a bunch of things to like about AIML. First thing is that I like, as an institute where we are heading, we are always pushing the boundaries of what's possible, from large language model to quantum computing, and of course, space technology. A lot of these fields, I think AIML researchers are playing the leading roles at the global stage. But personally, my favorites are the whiteboards. That's all over the place in AIML. Being able to sketch out an idea right there on the spot. It transcends words. There's a saying goes along the line of technology is indistinguishable from magic. And it really rings true to the things that we're doing here. Sometimes when you see this system come to life, it does kind of feel like magic. I feel really privileged to be a part of this journey.